Okay, hello class. Today we're gonna start with the topics for the third exam. So itong topics dito, wala na to sa, hindi nyo na exam sa April 30. Okay? Alright. So today's lesson would be Nature and Propagation of Light, yung part 1. Medyo kalahati lang ng chapter. Then next meeting would be examples. Tapos hopefully by that time, tapos na natin yung chapter ng for this topic. Okay? And then April 28th would be some review. I-checkan natin yung mga re-reveal natin yung mga sagot sa mga prob set and some additional review na lang din for your exam. Okay. So, yeah. Sige, start tayo. From the previous topics, nag-discuss tayo ng electric fields and magnetic fields. Okay, and then forces, tapos how do you calculate them, and etc. Okay, and by the end of the dito itong magnetic fields natin sa induction, na-produce natin yung mga Maxwell's equations, na kwento natin, na-chikahan natin yung mga Maxwell equation, and ano ba sila. Tapos nung kinumbine ni Maxwell itong mga equations na ito, he found out that light is made of electric and magnetic fields. Okay, so kapag you have electric and magnetic fields that are dancing together, you produce light. Okay? There's light. Okay. But how do you produce that certain kinds of fields? Okay, so how do you produce that certain kinds of fields, yung partner ng magnetic and electric field? Okay, nangyayari lang siya kapag nag-accelerate yung mga charges mo. Okay, so yung pag meron kang constant velocity na charge, magmumukha siyang current, and then kapag nag-accelerate pa yun, nag-increase yung current or nag-accelerate yung charge. Okay, so by that means, magpo-produce ka ng radiation or simply light. Okay, may equations done regarding dun. And then, ayun, ganun siya napoproduce. Ganun napoproduce yung mga bagay-bagay. So how do you accelerate atoms, no? One way is when you have sige, draw tayo. Meron kang light, yung energy source, which is kuwari sun natin. Tapos, nag-give off yan ng energy towards your atoms, towards your molecules. Kaya so may molecules yan, tapos may umiikot na electron. Okay. Pag inabsorb ni molecule yung energy coming from the light source, yung nangyayari is that nagbabago yung orbit ng electron mo. Okay, nagbabago yung orbit ng electrons mo. So by changing your orbit, you actually accelerate. Okay? And if you decrease your orbit, you actually decelerate. Okay, so yung action ng deceleration and acceleration is equivalent to producing light. Kaya pag nailawan yung mga matter natin, yan, nailawan sila, nakikita natin na may reflection nakikita natin na nagpo-produce ng light yung mga matter natin. Okay? So, kapag nasa loob ka ng room na walang ilaw, wala kang makita kasi walang nagpo-produce ng, ng at least visible light. Okay? So, what else? What else pwede natin gawin para ma-accelerate natin yung mga atoms? Another way is to heat them up. Okay? Pag ininit mo yung mga matter natin, obvious naman, di ba, na yung mga electrons doon sa loob, ma-excite siya dahil mainit siya. Okay? Pag mainit yung nagpa-vibrate ng malakas yung mga molecules natin, and in turn, nagpo-produce ng light. So, di ba, kunwari, nag-iihaw tayo. So, yung charcoal, kapag ininit mo siya, magiging pula siya, di ba? Umiilaw siya. So, ayun, nagpo-produce na siya ng light kapag nakatanggap siya ng large amount of energy. Okay, so that's light. So, when we have accelerating charges, they produce dancing, quote-unquote, dancing electric and magnetic fields, which is equivalent to producing light. Okay, so hindi na tayo pupunta sa math nun kasi it's a very complicated matter. But let's proceed into this chapter kung saan titignan na natin yung mga uses nitong light in our daily lives. Okay, so we ask first, is it a wave or a particle? Okay, si Isaac Newton, na hinulaan niya na yung light ay isang particle. Okay, corpuscles ang tawag niya. Yung time niya, 1600s. Pero of course, people didn't believe that kasi as you can see, light, parang yung light ay inherently wave. Okay? Kasi kung particle, dapat natatamaan ka, di ba? Parang nararamdaman mo dapat siya. Okay? So, for most of the time, wave yung tingin ng mga tao sa light natin. And then, dumating pa si Maxwell, which told us that light is indeed waves of electric and magnetic fields. Okay, so for most of the time, wave yung tingin natin sa light kasi by just observation. No? However, noong 1900s na, dumating na sila Planck, sila Einstein, and they have postulated quantum mechanics, quantum physics, that light is a particle which we call photons. Photons. Okay, so yung single quanta o quantum ng isang unit ng light is called the photon. And light is produced by quanta or by units. Ibig sabihin, there's no half unit of a photon. It can only be a unit of photon. Okay, so for every may certain light ka na binibigay, certain color ka na binibigay, whatever, red. Okay, so lahat ng photons na makukuha mo doon would look red. Okay, hindi siya pwedeng mag-iba ng hindi siya pwedeng pagka measure mo sa kanya, kalahati lang ng red, hindi pwede. Okay, so yung photons natin, meron silang energy na E is equal to hf. Okay, so si H ay yung Planck's constant, and then F is the frequency of the photon. Okay, so dependent yung itsura ng photon, yung property ng photon sa frequency. Okay, so yung H ay constant lang, tapos yung frequency would determine its color. Okay. Ay, may estudyante ako. Okay, pumasok na estudyante. Ayan. Hello, Leia. May bonus ka mamaya. Okay, so nag-start na tayo, Leia. Medyo i-backtrack mo na lang siya sa recording. Okay, basically, we're dealing with the nature and propagation of light. And good morning din. And kakasimula ko pa lang naman. Tinatanong ko pa lang kung wave or particle. And then, a recall would just be, yung light natin would be, for most of the time, inisip natin siyang wave dahil din kay Maxwell, nagbigay siya ng equations that tells us that light is a wave. And then dumating sila Einstein, nagbukas ng bagong field sa physics, and tinawag natin siyang particle. Yung particle na yun, yung light particles are called photons, and they have an energy of E is equal to hf. H is the Planck's constant. Planck's constant. Okay, and F is the frequency. Okay. So, yung light natin comes in units or quanta. Again, ulitin lang natin. Yung photons, gawa siya sa units. So, kumari red ay, yung red photons natin na may batch tayong photons na natanggap, which is red, kulay red sila. Wala tayong makikita lahat ng photons na makikita natin in that measurement would become red lahat sila. Ibig sabihin may certain frequency sila na related to red. Okay. And then wala kang ma-measure ng kalahating value nito. Laging by units siya. Okay? So, ayun. That's our particle of light, photons. And then, so by that time na-establish na nila Einstein yung field ng quantum physics, tinanggap na natin that wave and that light is both a wave and a particle. Okay. And then, light dictates the speed limit of our universe. Okay. So, itong speed limit na to would be the speed of light. So, si light lang yung pwedeng makaabot sa speed of light. Okay? Light lang pwedeng umabot sa speed of light. Nothing else. Pero some interesting things. Okay, so kumari, di ba may speed of sound tayo? Speed of sound. Okay? So may speed of sound tayo. If there is an airplane, okay, object. Pag meron kang object with greater than speed of sound, ang mangyayari, you create sonic boom. Okay? So, parang may sumasabog na event kapag na-reach ng isang object yung speed of sound, nagpo-produce siya ng sound, which is yung sonic boom. Okay, what if ma-exceed natin yung speed of light? If speed of light naman, what if pag na-exceed naman natin lang yung speed of light, if object exceeds speed of light, magpo-produce ka din. You produce light. Okay? However, di ba sabi nga natin, speed limit ang speed of light. Okay, but this doesn't limit us into into slowing down light. Okay? So, meron tayong, kunyari, sa inside water, mas mabagal yung speed of light. Okay? Sa water, inside of water, mas mabagal yung speed of light. And then, if you have something that is in the water that is going beyond the speed of, beyond that speed of light. Okay, kunyari, in water, yung light, V light is less than C. Okay? So, yung velocity ng light in water is less than C. Tapos, if in the water, you have something, a particle, kahit anong particle, parang may dumi, no, na traveling at near the speed of light, tapos greater than V light, okay, ang mangyayari is you actually produce light. Okay? Yung tawag ito, kuwari nangyayari to usually sa radioactive elements. Okay, so yung radioactive elements, di ba, pinaportray siya sa mga cartoons na umiilaw siya. Okay, so in vacuum or in air at least, hindi natin nakikita umiilaw siya. Okay, hindi talaga siya ganun. Pero, however, if you put them underwater, ang nangyayari is that umiilaw na ngayon yung radioactive elements mo kasi yung radioactivity ng element or nagbubuga kasi siya ng mga particles, mga electrons, helium atoms, or alpha particles. Nagbubuga siya ng alpha particles, no? So, yung alpha particles is just helium. Tapos, sometimes that helium particle or helium molecule exceeds the velocity of light in that water. Okay? Kaya nagpo-produce siya ng light, amazingly. Okay, so tinatawag yun na Cherenkov radiation. Okay? Kaya lang, fun fact lang, hindi naman siya kasali sa exam. No? Something nice to know. Okay, so when we have light, meron din syempre kung wave nga siya, di ba, tsaka particle. Therefore, it can be described as waves, and waves have wave fronts and rays. Okay, so kunyari ito yung itsura ng natin. Meron kang molecule dyan na nag-vibrate, na nag-accelerate. Magpaproduce siya ng spherical wave. Okay? So, ito, example dito would be sound waves. Okay? So, similar lang naman yung imagination process for sound and light waves. Ganyan. Ganun lang din. Okay. So, kunyari, pwede nyo rin isipin to na ito ay sun. So, meron siyang waves na spherical. Okay? Okay. And then, syempre, kapag meron kang wave, meron kang mga wave fronts. Ayan. Tapos, perpendicular to that is the rays. Tapos, si rays kasi yung usual lang gagamitin natin in understanding optics. Okay? Okay. So, magka-perpendicular si wavefront tsaka si rays. Okay? And then, pag parallel na syempre yung rays mo, parallel din yung wavefronts mo. Okay? Nangyayari yung parallel rays kapag malayo masyado yung light source mo. Okay? Katulad ng sun, kunyari yung sun, parallel rays na yung umaabot sa atin. Okay? So, sun. After sun. Pag tumama sa'yo yung light rays niya, yung shadows mo pantay. Okay? Okay? Unlike flashlight, kuwari magtapat buksan mo yung flash ng camera mo. Bukas ka ng flashlight ng cellphone mo. Pansin mo, na pag tumayo ka dyan, yung shadows mo would become like this. Okay? So, yung shadow mo, yung itsura niya, pero dito malaki. Okay. Kaya ito rin yung ginagamit na reasoning kung bakit hindi pineke ang moon landing. Okay? Kasi madaming nagsasabi, mga conspiracy theorists, na peke daw yung moon landing. Okay? Pero, ayan, kung titignan mo yung mga pictures, parallel rays yung mga shadows nila Armstrong. Okay? Tapos sabi nila, baka ginawa lang ng studio yung or computer graphics yung parallel rays. Okay, so by that time, hindi pa feasible sa computers yung ganun. Okay? Hindi pa sila feasible. So, mas practical magdala ng tao sa sa buwan kaysa gumawa ng bagong computer. Alright. So, ayun. Wala lang lang to. Feeling ko wala naman masyadong matatanong dito. Ayun lang. Yung idea must be dapat perpendicular yung dalawang object na to. So, yung wavefront, perpendicular siya with rays. Okay? And then, the important part ng optics would be reflection and refraction. Feel ko familiar na kayo dito kasi lagi siyang ginagamit sa sa mga exam and math ganyan. Sa high school, hindi nawawala tong reflection and refraction. Okay? So, sa example sa libro nyo, ito yung example sa picture. Merong glass. May glass pane dito, no? Tapos nilipad yung hat ni ate girl. So, yung hat mo, meron siyang light rays na binibigay. Okay? Yung light rays siya na binibigay and those light rays would bounce off the mirror, and that bounced off light is what we call the reflected light. And then, yung nag-pass through would become the refracted light. Okay? So, si ate girl, makita niya would be the image of the hat. Okay? And then, si kuya mo dito, makikita niya yung refracted image of the hat. Okay, weird nga dito, dapat medyo nakatagilid to noon. Ay, tama lang pala. Kasi manipis lang yung ina-assume dito na manipis lang yung glass pane. Okay. Pero kunyari mas makapal na onte, magbabago yung position ng image ng refraction. So magagalaw ng onti dito yung hat. Pero that's for next chapter pa lang. Okay. Okay. So in our analysis here, kaya natin tignan to. Yung B natin would be the glass pane. Tapos yung A, yung position nung kung nasaan si ate girl. Okay, so ayan. Dito yung hat. Okay. Ayan, dito yung hat. Tapos si ate girl nandito. For the simplicity of our discussions, yung mga rays natin, isa na lang yung ginagamit natin. Okay, para tayo mahirapan, isa lang yung gagamitin natin. Pero syempre, yung buong analysis would require all of the rays, di ba? Pero, ayan, dito muna sa kailangan natin aralin, paghihimay natin ng topic ngayon, hindi natin siya i-describe ng ganito. Okay, sa geometric optics pa tayo magpa-produce ng maraming rays. For now, ito muna. Okay, so again, meron tayong tinatawag na incident ray. Tapos, from an interface, itong AD interface, magkakaroon ka ng dalawang light. Okay, so merong refracted and then merong reflected. Okay, and then meron tayong tinatawag na normal line, which is yung line perpendicular to the interface. So, interface, itong patayo. So, dapat perpendicular yan dun sa normal line. So, yung sa position ng normal line would be on the spot kung saan tumama yung incident ray mo. Okay? Okay. So, from this line, dito ka rin magme-measure ng angles sa normal line mo. Okay? And then the refraction of the light is dependent on English grammar. It's dependent on the index of refraction, which is measured by the ratio of the speed of light in the different regions. Okay? Okay. So, si N ay yung index of refraction. So, C over V lang siya. Okay? C over V. Okay, minsan mahirap gamitin tong in practice, no, mahirap gamitin tong unang equation kasi mahirap mag-measure ng speed of light sa kahit saan, di ba? Mahirap mag-measure ng speed of light. So, pwede mo siyang actually gawin in terms of colors, di ba? The velocity of a wave, V, is equal to lambda. Its wavelength times its frequency. Okay? So, with this, N could be written as lambda naught times yung F. Tapos, divided by lambda over F. So, si frequency, yung frequency ng light, and again, ayun yung identity niya. So, hindi siya nagbabago. So, yung mga light particles natin, yung identification nila would be your frequency. So, kung ano frequency nila, ayun na sila forever. Unless ma-absorb sila somewhere. Okay? So, yung light mo, yung nagbabago sa kanya would be the velocity and its wavelength or yung color niya. Okay? So, yung frequency stays the same. Okay? And then with this, makita natin na this is just lambda naught over lambda, where lambda naught is the wavelength of the light in vacuum. Okay? Okay. So, ayan. So, mas madali dito sa second part kasi mas madali mag-measure yung color, di ba? Mas practical yun in lab. Okay, so now we turn into the laws of reflection and refraction. Okay, so yung una dito would be number 1, the incident, reflected, and refracted rays and the normal to the surface all lie in the same plane. Okay, so bakit to sinasabi? Kasi ito ay isang implication ng math ng mga waves kapag ginawa mo yung analysis dito. Feel ko medyo obvious tong unang-una. Pero it might not be, so let's discuss it. So yung una, sabi lang dito, dapat yung mga incident, hindi dapat, no? Lagi. Yung incident reflected and refracted rays, nasa isang plane lang sila. Okay? So, tinatawag natin yun as the plane of incidence. And okay, and this is perpendicular to the plane of the boundary surface between the two materials. Okay? Okay. Okay, so himayin natin dito sa part na to. So, meron tayong glass pane. I-drawing lang natin para malaman natin kung nasa yung plane of incidence. So, may glass pane. Yung glass pane natin, yung interface. No? Okay? Tapos, may ate girl tayo. Ate girl. Tapos, may kuya nakaupo. No? May kuya nakaupo sa loob. Yan. Okay, forgive my drawing. Okay, so, and then we have may hat tayo dito na lumipad. Yan. May hat na lumipad, tapos, lagyan natin mata yung mga tao. Yan. Okay. Tapos, ayan. So, yung light coming from the hat would go from here. Tapos mag-bounce siya. Pupunta dun sa mata. So, may point of contact doon. Okay. Tapos mag-bounce back din siya. Papunta dun sa taong nakaupo. Okay. So, this one is incident. Tapos this one is the reflected. This one is the refracted. Okay? So, yung plane of incidence would actually be the plane that is here. Okay? Ay, sorry. Tanga-tanga. Yan. Okay. Okay, so may plane dyan. So, kung top view mo siya titignan, yung plane of incidence. Ito si ate girl. Ito yung ulo ni ate girl. Ito yung lalaki. Tapos, may boundary ka. Okay, may boundary ka na ganyan. Tapos, may hat. May hat dito. Okay, and then meron kang ilaw. Yan. Okay, so ito yung top view niya. Okay, describe ko lang yung plane of incidence. Ayan siya. Imagine nyo na lang, no? Tapos, yung plane of incidence, it would contain all the light rays. Doon nakahiga lahat ng light rays. Okay. So, ayan. So, kunyari, tignan natin yung side view ng isang ilaw, no? Tignan natin yung side view ng isang ilaw. Kunyari, meron kang something dito, produce siya ng ilaw. Okay? Tapos, ano to mas malapit sa atin to, tapos mas malayo yun. So, going deeper into the page ito. Tapos, kunyari, may tatamaan siyang interface somewhere there. Ibig sabihin nung unang law is that diretso pa din ito. Kasi dapat yung reflected wave dapat nasa isang plane lang siya with the incident wave. Okay? So, ayan. Nasa isang plane lang sila lahat. Nasa isang line lang. Medyo hindi lang straight yung line ko, pero ayan, nasa isang plane lang sila lahat. So, Hindi siya pwedeng bumaba bigla. Okay. So kung bumaba siya, ibig sabihin, nasa maling plane tayo na tinitignan. So yung plane, kung bumaba siya na ganyan, would become yung plane na meron dito. Okay? Okay. So again, ayun. So may makakuha ka lagi ng plane that would contain all of this light rays. Okay? Okay. So that's the first one. Then the second one would be, ayan. So yung in this case, yung pag dinrawing na natin siya na ganito, ibig sabihin na yung plane of incidence is our page. Okay? Plane of incidence is our page. Tapos perpendicular siya sabi doon sa plane ng interface. Ayan. Perpendicular naman siya dito, di ba? Dahil out of the page ito. Yung line na to. Okay? And then, the law of reflection, alam natin to, no? Na yung angle of incidence equal lang siya dun sa angle of reflection. Okay? For all wavelengths and for any pair of materials. And from here, sure tayo na yung incident ray would be reflected back by the same angle. By the same angle. Okay? Measured from the normal line. Okay, and then lastly, the refraction, law of refraction is just this relation. Okay, or sometimes it's written as something like this. Sine theta 1 is equal to n2 sine theta 2. Okay. Okay, and then tinatawag din siyang Snell's law. Pero may debates regarding that na hindi naman talaga siya yung unang nakadiscover ng this part. Okay? Okay, so si N1 or si NA would be the index of refraction for the kung saan nanggaling yung yung incident light. Okay, and then NB would be the index of refraction for the material containing the refracted light. So in this case, tingnan natin, si theta A, then si theta B. Tapos meron ka material A, material B. Okay? Okay. So that's, alam na natin to. Feel ko, hindi na nga, na to. Obvious na sa atin itong mga ganitong bagay. Pero and recall. Okay? Okay. So some magandang sanity check. Okay, so when you have a low to high index of refraction, dapat yung okay, so low to high, ibig sabihin si material A, mas mababa yung index of refraction niya kaysa kay material B. So NB must be greater than NA. Okay, so low to high index of refraction. Mangyayari kapag ganun is that the incident light goes towards the normal. Ayan, towards the normal yung punta niya. Okay? So sanity check lang to, no? Hindi siya way of solving things. Okay, kunyari nagsosolve ka, no? Tapos alam mo na mas malaki yung index of refraction ni material B. Tapos ang lumabas na sagot mo, theta B greater than theta A, then ibig sabihin mali ka. Okay? For this case, dapat theta B is less than theta A. Okay? It's actually nice to write it down. NB. Pag NB greater than NA, ibig sabihin theta B is less than theta A. Okay? And then next is, kabaliktaran lang nun. Kapag high to low index of refraction, ibig sabihin, mas mataas dito. So, NA greater than NB. Therefore, the refracted light ray goes away from the normal. Okay? So, NB less than NA. Then it should be theta b greater than theta a. Okay? Okay, so what if, okay, so i-anuhan natin to, tignan pa natin to, no? May special case na mangyayari kapag vinary natin si theta A. Okay, so tingnan nyo to, i-rotate lang natin siya 90 degrees. Ito siya. Okay. So, syempre kapag normal yung incidence mo dun sa interface, syempre tatagos lang, di ba? Okay, so kapag umangle na tayo ngayon ng onte, si number 2, umangle tayo ng onte by amount of theta A, then we know that when NA, itong medium dito, mas mataas index of refraction niya kaysa dito, ang mangyayari, goes away from the normal yung refracted wave mo, refracted rate. Okay? So, at some certain point, si 3 naman tingnan natin, at some certain point, si 3, ang mangyayari sa kanya, at certain angles, theta critical, ang mangyayari is that yung refracted light ray mo is actually parallel doon sa interface mo. Okay? Ayan, pansin mo. And then, if you increase this theta critical, if you go beyond this critical, magbabounce off na actually yung light. Okay, so let's try to calculate this. N2 sine theta 2 is equal to N1 sine theta 1. Okay lang pagbalik na rin kasi equality naman ito. Okay, so for theta 2, ang gusto natin, theta 2 is that 90 degrees siya para maging parallel siya dun sa interface. So let's do that. Kapag nakaparallel na si theta 2 doon sa interface mo, so that's 90 degrees, si N1 mo nasa critical angle siya. Okay? Theta crit naman ito. Okay? Alright. So, si sine 90 degrees is just 1. So, therefore, we have this relation na sine theta critical is equal to N2 over N1. Okay? For N2 less than N1. Okay? Siyempre, para makuha si theta crit, i-inverse ano nyo lang. Hyperbolic ay sinusoidal. Inverse transcendental functions or inverse trigonometric functions. Okay? Yeah. Okay. So, yan. So, kapag umabot ka sa angle na to, mangyayari is that kapag nandito ka sa angle na to, mangyayari is that yung reflected ray mo is actually parallel to the interface. Okay? Tapos kapag if you go beyond this, magkakaroon ka na tinatawag nating total internal reflection. Okay? Okay. So, ayun. Ayan. Wala tayong sa Monday, tapos na tayo sa lesson ngayon. Naglatag lang ako ng mga equations today. I was not feeling well nung Monday tsaka kanina. Pero ayan. I think okay na. So, next meeting, we'll have examples to go with this kasi puro weird examples yung mga meron dito. No? Minsan may mga weird questions sa exam na confusing, ganyan. Okay? So we'll try examples next meeting. Tapos tatapusin na natin chapter next meeting din. Okay, and then so Thursday, we'll have a sort of a review for your exam. That would be checking your providing solutions with your prob sets. Okay? Providing a solution from the prob sets. So may bagong prob set, no? May bagong prob set. Deadline niya 27 para ma-practice lang yung yung sa induction. Sa induction tsaka sa inductance. Nag-upload ako nung Holy Week nung inductance na lesson. Okay, so that's it for today. Hindi ko sure kung mag-i-include ng topics doon sa sa RL circuits. Okay. So sana wala. Pero you can understand that yung RL circuit. Katulad lang siya ng RC circuit. Very similar. Okay. So nag-RC tayo last time. Pero sana walang RL ngayon. Kung meron man, you can try to read it. Okay? Check ko rin naman check ko rin yung mga tanong sa exam, next meeting. Para malaman ko kung may may heads up kayo kung may mga topics na hindi ko nasama sa lecture. Okay? So, ayan. Yeah, that's it. Mag-record lang ako attendance.